Senior Director of Education for American Wood Council. And I feel very humbled coming after the previous presentation because I just represent, I shouldn't say I represent the U.S. related to wood construction, and I'll get a little bit more into that. So this presentation is going to look at the history of wood construction throughout the world and throughout the U.S. And my organization is the American Wood Council, and we've been in existence in another form or another since 1902. And we changed names in 2010 to the American Wood Council. And we represent the building industry, the wood products industry in the building industry related to the standards for developing guidelines for designing wood structures. And we also deal with the codes. So we deal with codes and standards related to construction of buildings in the U.S. And these show you a little background about the publications we developed throughout the years, starting out in 1944, the National Design Specifications for Wood Construction. And the most current one is the 2015. But we deal with the gravity loads, the seismic loads, wind loads, and providing provisions for designing structures so that they're designed safely. And then, so I'll start off now with my presentation dealing with buildings. And previous to joining American Wood Council, I was with an organization called Woodworks, and I joined that organization in 2008. Previous to that, I had about 20 years of experience as in the private sector as a structural engineer. And I started college when I was about 5 years old. So a little humor there. So in 2008, when I joined Woodworks, I knew wood structures and the building of wood structures as shown here. Typical stick frame construction, there's residential construction. This is called podium type structures where we have 4 or 5 levels of wood construction on a level of concrete podium or multi-story construction. So that was what I was used to. But then when I joined Woodworks, it opened my eyes to what really is going on in the rest of the world. Here is what's shown, a building that was completed in British Columbia, in Canada. And I'll highlight these structures just to give you a feel for what we're going to be talking about. And this is actually in California, high seismic zone, prone for earthquakes, up in Oakland, California. Now, I was fortunate enough to visit this cathedral, and it's so peaceful inside when you walk inside. Not just because it's a church, but because of the exposure of the wood that you see, the warmthness of it. And this is one of the first cross-laminated mid-rise structures in the world. This was the tallest one that was completed in 2009, where the entire structure, except for the first level was concrete, and then 8 stories of cross-laminated timber. If you're not familiar with what laminations is, we have glue lam beams that span as a beam. They have thicknesses of wood that span the entire distance, and that they act as a beam. With cross-lamination, you have one lamination in a layer, a bunch of laminations, and then 90 degrees to that, the next layer is changed, and then so on and so on. So they call it plywood on steroids, but it's laminations of wood. And they come out in big planks, similar to what you would see at precast concrete, or I don't know if you're familiar with tilt-up panel walls. They're all big planks. These are similar to that, where the entire building can be made out of cross-laminated timber. So this is in the UK in 2009. And this is a very interesting structure, and it's to the very top of the spiral. It's 245 feet tall, but the organic look or how the waves of the wood and how it's curved organically is pretty impressive of what they can do with wood structures. Something we don't always think of wood having the capability of doing, spanning far distances and reaching high heights. This is the largest wood structure in the world, and it's about 85 feet high. I should get my notes out. In Seville, Spain, using LVLs, that's laminated veneer lumber. So when I joined Woodworks, this really opened my eyes on what's going around the world. There's a lot of structures being built out of wood. The U.S. is actually kind of far behind on what is actually happening, and their acceptance of actually using wood in large structures, we're kind of lagging behind. And that's one of the goals of American Wood Council, is to educate, open the eyes of architects, engineers, and building officials on what you can actually do with wood. And so this is a quote I'd like to share is, if the 19th century was a century of steel and the 20th century was a century of concrete, then the 21st century is about engineered timber. Now, looking back at history, wood has actually been used in structures for quite some time. Here's some structures dating back to 711. Maybe someone can help me with the pronunciation, but this is in Japan. Oh, thank you. Oh, thank you. And then in Norway. And this is probably one of the first mid-rise structures in the southern hemisphere in New Zealand, and they're still standing. And so they do have the durability because some people wonder when you use wood, are they going to have the durability to stand the test of time? But then when you think about it, here in the U.S., we have trees that are 3,000 years old. There's the giant sequoia, western juniper, that's 2,000 years old, and the bristlecone pines that are 5,000 years old. I actually was able to visit that at one time. But we have trees that are still existing, still standing, and they are durable enough to stand the test of time. So there's evidence that wood structures, if we know how to detail them and design them, they can be able to be designed to stand the test of time. It's just understanding the product, which I'm sure all of you know a lot more about wood than I do, as far as from what I've seen out in the expo. And here's some more recent history of historical information here in California, where we have the Marine Corps Air Station in Tustin that was built in 1942. And the history behind this is that during World War II, a lot of the steel or the metal was used towards military. We know that. So they had to build structures, and they utilized wood. And these are very tall structures. And then bringing it back to actual buildings, right now we are limited in the U.S. to only go to 6 stories high. That's what we're allowed to do, depending on the occupancy. Yet there is a history of structures that are taller than that. This is a 7-story heavy timber structure, warehouse, over 2 stories of concrete. And this is another example of a 7 stories heavy timber with a brick facade, and a 6-story in Texas. And all of these are warehouse type buildings, so there's quite a bit of load on these structures from a vertical standpoint. And this is probably the tallest warehouse heavy timber structure, which is, I believe, 9 stories. Yet, the code limits us to only go to 6 stories. And that's where we are at American Wood Council, is trying to expand that so we can go taller. And so looking back at the history of what is developed throughout the world and why architects, specifically architects, want to incorporate wood into buildings. Some of you may be familiar with climate change, but this is just a very high level of what is going on or what the thought process is. And that is, one, we have solar radiation that heats up the earth, and the heat radiation then goes back out into the outer space. However, there's a gas level around the earth that has greenhouse gases, which are made up of these. There's some of the major gases that make up this layer. And for this gas to escape out, there's such a level that it's not all able to bounce back out into the outer space. So then we have a buildup, and some of this gas is made by human activity, as we know. One of the major gases that we are concerned with, or some people are concerned with, is carbon dioxide. And that's why there's such an emphasis to reduce our carbon dioxide emissions. So that's where, when we look at buildings and what we utilize as materials for buildings, we look at the whole life cycle assessment, what it takes to create a product, to get it to the job site, where that resource is coming from. And that's why the building industry, especially throughout other countries, are embracing the material of wood. Because the other major materials, one, it's not renewable. Wood is renewable when it comes from a sustainable forest. The other materials aren't renewable. They can recycle them, but it takes a lot of energy to recycle those materials. Also, wood stores carbon. It's 49% carbon dioxide, so it stores it for long-term storage until it's disintegrated or burnt or whatever, then it goes back into the atmosphere. So they're using this as a more sustainable way, a greener way of building. Obviously, the greenest, more sustainable is not to build at all or to reuse a building, but that's not always possible, and we're always going to want to build. That's our nature, to want to build buildings. So using a very conscientious choice of using wood is what people are choosing. The other aspect of why wood is becoming more popular is because they want to be good stewards of the earth. They want to make sure that they're not utilizing resources that can't be replenished. So this is one example. If any of you have heard of the Kyoto Protocol, where some countries have agreed to reduce their carbon emissions. One of those countries is the UK. And they state that in that agreement that they are to have reduce whatever building they build, they need to have renewable energy. They have to have zero impact on the environment as much as possible, but one of those measurables is renewable energy. And renewable energy is really expensive. So the owner and the architect work together to say, well, when we use wood, we are actually storing for this structure, we're storing 300 metric tons of carbon dioxide. And that equates to about 21 years of building energy usage. So they were able to offset that requirement of renewable energy by using wood structures in the structure. And I'll get more later. So the other reasons why we're seeing a shift to using wood in structures is technology, understanding more about the wood material, being able to make wood materials stronger with engineered wood products. Also technology regarding fabrication, using CNC technology to more accurately construct structures. And then prefabrication is also another reason why they're going to wood products. And I'll show you some examples of these three or four reasons why. So that bridge there is a heavy timber bridge and has heavy traffic and spans, let's see, I gotta look at my notes. It spans 105 feet, spanning that. Here's another bridge in British Columbia, and it spans 145 feet. It does have pedestrian traffic, and it utilizes the strengths of actually 3 different materials. So a higher technology combining wood, masonry, and steel. And we have a PT concrete, post-tension concrete slab is the walkway. We have glue laminated timber that is the arch, and also tension rods that's part of the steel structure that acts as the roof. And this is more about the cross-laminated timber building in the UK. The other unique aspect about wood is that as opposed to using steel or concrete, which are very heavy materials, wood is lighter. That means that there's less seismic load because the seismic is based on the weight of the building. Also, the foundations are lighter because you're supporting a lighter structure. And the corner there, because of the prefabrications, all of the CLT panels were fabricated off-site and using CNC technology. So they go together very accurately. When they get to the job site, it goes up very quickly, which saves money as well, because the cost of construction can go up the longer you spend on the job site. With the prefabrication process, they were able to erect it very quickly. And then related to noise pollution, on the job site, it was very quiet as opposed to a traditional stick frame type project, because you hear hammers, nails, drills, and all of that. A lot of loud noises, a lot of workers when they're erecting a traditional wood structure. With this structure, the noise was quite a bit less. They just had you see the crane that would lift it in place, and then here is the waste of the dust from the job site. Whereas traditional projects, you may see a lot of waste because of the cutting and all of that. And that's the interior. So this is the cross-laminated timber. It kind of looks like plywood on steroids. And that shows you kind of a graphic of what cross-laminated timber is. So what they do is they lay out the, say, 2x4s all in one layer. Then they apply adhesives, and then the other layer gets applied, and they press it in place and allow it to cure. So this shows you the speed of construction. This shows you per week. And the construction time was half the construction time it would be with precast concrete. So 9 stories built in 9 weeks. Here's an example of technology utilizing wood. This is in DC, Washington, DC, the arena stage at Meade Center. And this was a restoration project. It's a existing project that had concrete and steel trusses. These parallams, which you see here, columns, are supporting steel trusses. And the engineer designed a connection here that allowed some versatility or movability of these columns that support this exterior facade of glass to pivot about a point so that they had some movement in that for connecting it to the existing trusses. And this is going back to a little bit more detail about the Cathedral of Christ the Light in Oakland. It's 108 feet tall and uses a glue laminated timber louver system. And then there's vertical glue laminated timber that is supported back on that louver system that supports the glass facade. And they use tension rods as well for the lateral. But what they wanted to do is this is designed to be a 300-year life building and to withstand a 1,000-year earthquake. It's on a base isolation system. This shows you a mock-up of the test that they performed on the louver system. And then airports, something that we don't usually think of when we go into an airport. I don't know if any of you have been into LAX. It can be quite sterile, white everywhere. I actually visited. I flew into this airport, and I was just amazed at the warmthness of these glue laminated timbers that it provided. So it used a glue laminated timber arch and tension rods on the bottom, so utilizing both steel and wood. And this is from my alma mater, Cal Poly San Luis Obispo. This was first going to be a steel building, and they decided to use heavy timber construction and brace frames, wood brace frames. And this gets back to the Richmond Olympic Oval, where these trees were infected with a mountain pine beetle, and to get rid of that mountain pine beetle, those trees, they'd have to burn the forest pretty much. So instead of doing that, they harvest the trees, and the engineer thought outside of the box and came up with this innovative wood wave. And it spans, I think, about 25 feet, and it uses a 2x members all nailed together and tension rods on the bottom. You can see this is the wood wave. And they span to these arches that are glue laminated timber steel truss arches that span over 100 feet. One thing nice also is they were able to put some MEP sprinklers through that system, which can be a challenge in architecture, in art buildings. Yeah, they spanned 300 feet actually. So now coming back to the US, all of those really beautiful structures were in Canada or Europe, and we're hoping to educate the US on how to use wood. This system, which is nail laminated timber, has actually been in the building code since 1967. And what it is, here's a structure here in Culver City, California, Southern California, that utilizes 2x12s, just your typical framing members, and connects them all together using nails. So it's a solid plate, a solid floor system, all out of 2x4s. And it's interesting, I gave a presentation to code officials yesterday, and they were just amazed that this system works. But it's been in the code since 1967. Prescriptively, meaning there's a recipe on how to connect it all together, and they were just amazed that people are using it, or even why someone would use it. So this gives you the code references and how it's all connected together. This just shows you how the nails are staggered from one 2x12 to the next. But the architects really want to see that visually pleasing look of the wood from underneath. This is up in Portland, Oregon, where they're utilizing nail laminate timber. And there's a construction category that's becoming more and more popular now throughout the US and North America. It's called mass timber construction. It's not really defined in the building code, but what it is using smaller pieces of wood to create big pieces of wood, such as 2x12s to create a big floor system, or cross-laminated timber to create a floor system, or even glue laminated timber laid flat to create a floor system. And so this is the inside. You can see the nail laminated timber here, which is just 2x nailed together, and the heavy timber construction. And so I was fortunate enough to go on a tour of buildings in the Pacific Northwest where this is really taking off. And we ran into a developer, and I actually asked a developer, what's the reason for using this? Because developers, they want to get there fast, and cost is an issue. And these buildings are kind of comparable to what a steel or concrete would be as far as cost, but one reason why they're using this type of construction is because of the warmth environment that it provides. Usually in an office building, you're in cubicles, you have the white drywall walls and ceilings or suspended ceilings, and it's not inviting. So they're using this as businesses are using this to recruit people to come work for them. It's a very, especially in the high-tech industry, where there's a high demand for good people, employees, and they want to get the best of the best. So this is one reason why, is so that they can dangle this carrot and say, you can come work in our office, and we have this really warmth environment. And this is one of the first nail laminated timber projects, probably in that area, in Seattle, where it was touted at this time of construction. It was 2012, where they wanted to have the greenest building in the world, touted as the greenest building, and they used nail laminated timber as well. So the aspect about nail laminated timber, I mentioned prefabrication was one of the reasons why they're going more to use wood, is that nail laminated timber can be done in the shop, prefabricated and erected in modules, such as shown here, and all the connections done off-site. Then they can ship it to the job site and build it very quickly. They also can do some different configurations. This is actually nail laminated timber, where you have a 2x12, and then the next one to it is raised a little bit, and the next one is raised a little bit and raised a little bit, and it creates a curve when the elevation of that is changed. And then it used a tension wire on the bottom. And this gets back to the largest wood structure in the world, which is the Metropole Parasol, utilizing LVLs, laminated veneer lumber, and it's coated with polyurethane coating because of the exposure to the environment. But some background behind it, there is an existing subway station below where the structure that they were providing couldn't be very heavy. And so they looked at all these different materials. They wanted a really large structure, and the answer to that was to utilize wood because it's a lot lighter than the other building materials. Because they were dealing with existing foundations and they were dealing with the existing subway. And this is, I just like to show this because I like this building, is the artistic creativity of Art Gallery in Ontario, Canada. The architect is Frank Gehry, and utilizing glue laminated timber. Each of these glue laminated timber are at various degrees as they go throughout that facade. And so every single connection was different. And that's one great thing, characteristic about wood, is that it can be used, the connections can easily transfer using CNC technology, and machinery can be easily adapted to the different connection orientations. This is a really informative website called Rethink Wood, and it has information related to tall wood buildings in the world. AWC is working in the U.S. on a tall wood effort to be able to design to taller stories than what we are restricted to now is 6 stories. If you go to the rethink.com website, it has this library of all wood structures. Some of them are conceptual, some of them are real. You can click on each one of them and it'll provide a lot more detailed information about the actual building. And I'll skip through this. One of the largest mid-rise constructions in the UK, all out of cross-laminated timber except the first 2 stories. It's concrete. This is in Austria. So throughout the world, they're utilizing cross-laminated timber. And Italy. And this was the largest cross-laminated timber in the world, or wood building in the world, 14 stories in Bergen, Norway. And this is a conceptual international project to go to 35 stories utilizing wood. And then now bringing it back to North America, we have the 8 stories Wood Innovative and Design Center. I'll be through in a minute. And I was able to tour this building, the Arbora in Quebec, Canada, 8 stories, utilizing cross-laminated timber and heavy timber beams and columns. Now, this is the tallest building in the world out of cross-laminated timber, 18 stories. The first level is a concrete podium, and the rest are cross-laminated timber in British Columbia, Vancouver. And then bringing it back to home, there is a project that's now going through the building department in Oregon, 12 stories of cross-laminated timber. So the first level is concrete, and then 11 stories of cross-laminated timber. It won the U.S. Tall Wood Building Competition. And then we have in the U.S., this is, I believe, the tallest now in the U.S. currently. So this is where I started off in 2008 when I joined Woodworks, and now I'm with American Wood Council. I just wanted to finish on a very creative architecture in Culver City, Southern California building that was a existing, I believe it was a masonry building, and they wanted to add another level to it, and they utilized glue laminated timber system to provide a very organic, creative use of wood. And that's it. That ends my presentation.